In this video, I'm going to introduce you about how to verify, how to show that two straight line in space are perpendicular line, and to show that how L1 and L3 means that two lines are parallel lines. Alright, the methods of showing two lines are perpendicular line and perpendicular and parallel line. Alright, for example, there is the question asking to show that, okay, this is a concept, so show that L1, L2 are perpendicular line. Alright, so means that how to showing that L1, L2 are perpendicular line. To showing whether something is perpendicular or parallel, we usually using the direction vector. Alright, we need to identify the direction vector of the line. Right? So means that the direction vector here refer to R equals to A plus TV, because the direction we're telling you whether the two line is perpendicular or parallel. Or is the important thing, you must get the direction vector from the line. Alright, for the first line, the direction vector, alright, for the first line, the direction vectors can be very easily taken. Because why? R equals to A plus lambda V, right? V. So parameter, after the vector that the scalar multiplier between the parameter and the vector, this is actually a direction vector, which is 1, 2, -1, right? 1, 2, -1. So I have get the direction vector. Okay, I label it as V1 for line 1. So the direction vector for line 2, you can rewrite this to be in parametric form. Alright, you can transform this to be a parametric form. So by writing x minus 2 over with -3 equals to t and y plus 1. So since that this is already using t and this is using lambda, so I will letting this to be s. Alright, S. So to show that this is three different lines. So lambda, the parameter for line 2 will be S, and for line 3 will be T. So y plus 1 over 4 will be equals to S, and Z minus 7 over 5 equals to S. Alright, and you rewrite it. If you rewrite, you are getting X equals to 2 -3S. Alright, 2 plus -3s, and y to be -1 plus 4s, and z to be +7 plus 5f. Okay, +7 plus 5s. So as you see that the coefficient means that the direction vector for equation, right, for the straight line of this straight line 2, so will be -3, 4 and 5, right? So this will be the direction vector for line 2, right? So sometimes students, when they are already expert, they can straight away directly take the coefficient here. But once you take the coefficient, so means that you take the number of the denominator. You see -3, 4, and -3, 4 and 5, right? -3, 4 and 5. This is even faster, but you must be careful. While you're doing this way, you must make sure the coefficient for x is 1 and +1, alright? Since all here is +1, so you can take the denominator as your direction. Okay, -3, 4, 5. So how about line 3, right? The direction vector for line 3. So the direction vector for line 3 will be the coefficient of t, -1, right? -1, -2, and 1, right? So the most important thing, you want to show the straight line is perpendicular or parallel, the direction vector is very important. Alright, so I have direction vector for each of the line, right? So now let's look at part A. Alright, now let's look at part A. So part A, to show that L1 and L2 are perpendicular, so we have to using the V1, 1, 2, -1, and V2, which is -3, 4, and 5, right? So from your knowledge of scalar product or dot product, right? Dot product. So if two vector is perpendicular, means that A perpendicular to B. If A is perpendicular to B, therefore the A dot B will giving you 0, a scalar, right? So we're giving you a 0. So to prove that two lines are actually perpendicular to each other, means that the direction vector have to be perpendicular to each other as well. So very simple, you just need to take V1 dot with V2, find the scalar product of the direction. So 1, 2, -1, dot with -3, 4, 5. So you just calculate 1 times -3, doing scalar product, plus with 2 times 4, which is 8, -5, right? So -3 plus 8, getting 5, 5 minus 5, you're getting 0. Can you see that? You're getting 0. If the dot product is not a zero number, this shows that the lines are not perpendicular. But because of the dot product of this direction vector gives us 0, this followed by this concept here. So if A dot B is 0, this one shows that A and B are perpendicular to each other. Means that the line are perpendicular to each other. So you have to explain, since the direction vector, right? You have to tell them the direction V1 dot V2 is equal to 0. Therefore, L1 is perpendicular to line 2. Alright? Based on the direction vector. So to show that something is a perpendicular line, that is the best way. Alright? That is the only way, and we're using dot product, and we show that after the dot product of the two direction of the line getting a 0, this show that these two lines is actually perpendicular to each other. So let's see how to showing a line is parallel, the two lines are parallel to each other. So for parallel line, we have two methods that recommended, right? For this, to show two lines is perpendicular, this is recommended. Alright, we're doing dot product of the direction vector. If we're getting 0, then the two lines are perpendicular. Alright, let's look at part B. Alright, let's look at part B, how to showing that two lines are perpendicular. Are parallel. So if I say that a vector A is parallel to vector B, so we have two methods to showing that. If you want to show that vector A and vector B is parallel, right? It's parallel. So I can say that A is a multiple of B, right? It's a K, and K is a scalar. Okay, it's a scalar quantity where the vector A can be rewrite as a K times the vector B. As long as you can show that it's a multiple of another vector, then we can say that these two vectors are parallel. Or we also can using cross product. If A cross B is given you a 0 vector, then you also can prove that these two vectors is actually parallel to each other, right? Based on the properties of cross product that I discussed before. Alright, for these two methods, either one will be okay, but usually this will be recommended because it's a lot easier. So now between line 1 and line 3, right? Line 1 and line 3. So we need the direction vector for both lines. So means that we need the direction vector for line 1, 1, 2, -1, right? We need the direction vector for line 3, which is -1, -2, 1. Right? If you see that this is very easily, you can rewrite V1. If you see 1 negative, this is 2, this is negative, this is -1, this is 1. So means that they are negative of V3. Right? So means that if you see carefully, negative 1, you get it positive. Negative, you're getting 2. -1, you're getting -1. Right? So V1 is the negative of V3. You have already shown that A is K times is -1 V3, right? So since with this statement is already good enough, alright? So since V1 equals to negative direction of V3, so therefore V1 is parallel to the line, right? Line L2 is parallel to line 3, sorry. line 1 is parallel to line 3. So because of this statement here, the direction vector is parallel, right? If written here, if this v type v1 is to the k negative of v3 or k, any number here, all right? This shows that these two vector, the direction vector, is actually parallel to each other. If the direction is parallel to each other, means that the line is also parallel to each other, all right? So this is the first way. So another way will be using cross product. All right, let's see. All right, now we're going to using cross product. We're going to using V1, right, cross with V3, because we want to show that these two lines, line 1 and line 3, are parallel line. So we take the direction vector of both the line and we're doing cross product and see. So the cross product will be I, J, K. All right, have you learned before in my previous lesson? So under the concept of cross product, I have shown you that. So how to doing cross product? So your V1 will be 1, 2, negative 1. All right, and your V3 will be negative 1, negative 2, 1. Right. So let's do cross product. So as this will be positive, right? Positive, negative, and positive of k. So what is the number here, right? So I, right, for I. So we delete the row, delete the column. So we have 2, negative 1, negative 2, 1, right? And for J, delete the row, delete the column. So 1, negative 1, negative 1, 1. So for this K, delete the row, delete the column, 1, 2. 1, 2, negative 1, negative 2. All right, and let's calculate. So we have 2 times 1, 2. Negative with negative 2 times negative 1. So we have 2i. So negative 1 times 1, 1. Minus with negative 1 times negative 1, 1. J. Plus with 1 times negative 2. So we have negative 2. Negative 1 times 2. So you have negative 2. So K. If you observe, if you calculate, you are getting 0i, right? You are getting 0i. Very special. Once you're getting 0i, and this is also 1 minus 1, 0. You can just write as 0j, positive 0j. And negative 2 plus 2, you're getting 0k. This is actually a 0 vector. So if you show that A cross B is a 0 vector, this shows that V1 and V3 are parallel to each other. Alright, so if V1 and V3 are parallel to each other, therefore L1 and L3 are also parallel to each other because the direction of the line are parallel to each other. Alright, so this is the other way of proving, showing that two lines are parallel by doing cross product to show that it's getting a 0 vector. But between these two, I will recommend this because this will be faster, right? So, okay, that's all for this concept. Hope that you can apply when you're doing your exercises.